Hi and welcome to Math Pre-Calculus 20, Section 5.2, Example 2. Alright, so this one we're kind of applying the idea of radicals. So it says an artist frames an equilateral triangle inside a square. The area of the square is 32 centimeters squared. Okay, so basically it's like this picture over here. Inside here they've framed an equilateral triangle inside a circle, but instead in this question it's inside a square. Right, so it'd be like something like that. Okay, so we could start with a square, which is this one here. So we have a square, and then there's a triangle that's equilateral that's gone inside it. So basically, all three sides of the triangle is going to be the length of this bottom here. And so if we look at that, we realize that we can't actually go all the way to the top with this triangle. So if we go all the way to the top, it's going to be longer than that bottom side, and all three sides need to be the same. So it's going to be something like that inside there. Okay, and so for this triangle, all three of those sides are the same. On this square, all the sides are the same. And basically, on a square, like if this is S, and we know the area of the square, right? The area is 32 centimeters squared, and the area of a square is equal to side times side. So basically we have that 32 equals s squared, and then we could solve that by square rooting both sides. Plus or minus isn't necessary because we want a positive side length. So that means the side length of the triangle end of the square is going to be square root of 32, which simplifies to be, right, square root of 32 is 4 times 4 times 2, so 4 square root 2 centimeters. So basically, all four sides of this square are 4 square root 2 centimeters. And since, right, this is 4 square root 2, that means this is 4 square root 2, and that means this is 4 square root 2. So this question here asks for the perimeter. So the perimeter is just going to be 4 square root 2 plus 4 square root 2 plus 4 square root 2. So it works out to be 12 square root 2 centimeters. So that's the perimeter. So that's part A. Okay, and we got that from the fact that the area is 32 centimeters squared, and since it's a square, it's just going to be the square root of the area, gives us a side length. Okay, part B, we want to know the exact height of the triangle. Okay, so the exact height of the triangle, if we've got this triangle, we've got that each side is 4 square root 2, and what we want to know, right, is that there. How tall is it? What's h? Well, since it's equilateral, and I didn't draw this perfectly, but since it's equilateral, each part here, right, is going to be half of 2, or a half of 4 square root 2. Right, so half of that is 2 square root 2. So that's 2 square root 2 centimeters long. So then we could just use Pythagoras, because basically now we've got, right, a right triangle here, and we know 2 of the sides and we don't know the third one. Right, so the hypotenuse is 4 square root 2, so that's going to be 4 square root 2 squared equals h squared plus 2 square root 2 squared. Okay, then simplifying this and solving for h, that's what we want to do here. Solve for h, this becomes 16, then times the square root of 2 squared. Well, when we square a square root, we just get the number, so 16 times 2 equals h squared, plus, and then 2 squared is 4, square root of 2 squared is just 2, and then working this out, we've got, going to have h squared equals, this part here becomes 32, and then take away 4 times 2 is 8, so h squared equals 24. And we don't want to know the height squared, we want to actually know the height. And again, we don't need the plus or minus because it's a height. So the height of that triangle is a simplified version of square root of 24 centimeters. So 24 is 4 times 6, or 2 times 2 times 2 times 3, or 2 times 2 times 6. So 2 square root 6, and it's in centimeters. Alright, so that's the height of that triangle. Okay, quite a bit of work there, but hopefully that makes sense. Okay, Okay, and then the last step here, what's the area of the triangle? Right, well, area of a triangle is equal to 1/2 base times height. So we've got 1/2, and the base is the distance all the way across. So that's 4 square root 2, and the height is 2 square root 6. So we just need to simplify that. So that's 1/2 times by, and this becomes 8 square root 12. We can multiply the 1/2 and the 8, which is 4, and then square root 12, and then square root 12, right, is 2 times 2 times 3, so it becomes 4 times 2 in front, so 8 square root 3. And then since it's area, right, it's going to be centimeters squared. Okay, and again, so that's just kind of a neat little question where we get to have a context to actually work with these radicals as opposed to just randomly working with some radicals. So that's, I don't know, kind of fun. I'm sure you agree. All right, thanks for watching.